All right, next up is the PI. The PI is our isoelectronic point. And you can probably tell it has something to do with acidity, basicity, right? PI, pH, pKa, that kind of thing. So the PI is defined as the pH at which the concentration of the Zwitter ion form is the highest. So at what pH do we get mostly the neutral compound? Because remember, the Zwitter ion is the net neutral compound. Um, so isoelectronic point isn't too bad to calculate for a neutral R group. It's simply the average of the two pKa's. And that makes sense, right? Right in between the midpoint, that's when we should see the maximum amount of our either protonated or deprotonated form. So for example, alanine would just take 2.34 plus 9.69, divide by 2, and then we get 6.00. And then if you're wondering what that compound looks like, it looks something like this, right? Where we can see our net neutral compound. We have a positive and a negative, and they cancel out. However, what we can see is some of our amino acids contain three acidic or basic components. And so how do we calculate the PIs from that? Right, on an exam, you won't be given this PI table part. You'll be asked to calculate it from these three columns, and then, of course, a picture of the compound as well. We won't expect you to memorize the structure of these compounds. So for the acidic slash basic R groups, the PI is going to be the average of the two pKa's that are involved in forming the Zwitter ion. And so what we want to do here is just basically start with a fully protonated form of the structure, and then we're going to deprotonate starting from the most acidic compound. And remember, when we're talking about our fully protonated version, our nitrogens are going to be protonated. They're going to be a positive charge. Our oxygens are also going to be protonated, but they are going to be net neutral. So just an OH, for example. No extra H, no positive charge, that kind of thing. So let's take a first look at tyrosine. We can see our values are 2.20 for the carboxylic acid, 9.11 for the amine, and then 10.07 for our R group. Again, you're going to be given the structure of these compounds, so you don't have to know the structure, but you may be given them in net neutral forms, where all of our R groups and heteroatoms are neutral. So maybe, for example, something like this. However, remember, we're going to start with our most acidic form, so we're going to protonate everything, and that necessarily means our amine. So our amine is going to be positive, so we'll do NH3+. And its pKa was 2.20, the carboxylic acid was 9.11, and then this alcohol over here is 10.07. If we think about our compound right now, it has a charge of +1, right, from the amine, and then no other charges. So then we think about what we're going to deprotonate first. You're going to deprotonate the most acidic group first, which is the lowest pKa. So that's that 2.20. So somewhere around 2.20, we're going to really start deprotonating this amine, and then we'll get this next structure. And then if we think about our charges there, that charge is net neutral. So that is our Zwitter ion. And remember, we need to be able to draw these. So understand how to come up with the Zwitter ion, what's protonated, what's deprotonated, that kind of thing. So we see that on one side we have our 2.20. So then we're going to keep going to see what the other side of the Zwitter ion is. So our next most acidic component is going to be this 9.11. So that's the other number we're going to use to calculate it. Technically, you don't have to draw this next compound, but we will. So our amine is already deprotonated. Our alcohol down here is remaining protonated, and then our carboxylic acid gets deprotonated and it goes from being an OH to now an O minus. Our net charge is now at a -1, right? And so then after that, we can just calculate our PI. So our PI will just be 2.20 plus 9.11 divided by 2, and I get 5.66. Let's check if that's correct. And yep, looks like it's correct. Let's go ahead and do one more example. Let's do glutamic acid. So we see we have 2.19 for the carboxylic acid, 9.67 for the amine, and then 4.25 for our R group. So in this case, we can see our R group is slightly more acidic. So let's go ahead and draw glutamic acid. And again, you'll be given this structure from a table. And then we said our carboxylic acid was 2.19. Our amine was 9.67. And then our other carboxylic acid, which is an R group this time, is 4.25. It's interesting how big of a difference these two carboxylic acids are. You can think about your acid-base reasoning, potentially the inductive effect of why one of these is significantly more acidic than the other. Right, so given this type of information, we should be able to calculate our PI. So step one, we're going to draw everything in our protonated form. Remember, our oxygens are going to remain neutral. Just draw both of those as neutral. And then our amines will be protonated, so they'll be NH3+. And so you can see we have a net charge here of +1, so that's not our Zwitter ion yet. And then we're going to start deprotonating things, starting with the most acidic component, which is going to be our lowest pKa. Our lowest pKa is this 2.19. So somewhere around 2.19, we're going to see significant amounts of deprotonation of our carboxylic acid on the right there. And then this is going to go from an OH to an O minus. If we think about our charges now, we have a +1 and a -1. Those two will cancel out for a total charge of 0. And so this is what our Zwitter ion is. And again, be able to draw the Zwitter ion. All right, next up, this next component, I guess you technically don't need to draw the compound, but we will. So continuing on, we're going to then deprotonate our next most acidic compound, which will be this 4.25. And in this case, it'll be the other carboxylic acid that's going to go from an OH to an O minus. And then we'll just draw out the rest of the structure. And then you can tell our overall charge there is -1. And so what we're going to do is take the average of the pKa's to the left and right of our Zwitter ion. So it'll be 2.19 plus 4.25 divided by 2. And then I get 3.22. And then we can go up to our little table just to double check ourselves, and I get 3.22. Note that these values in the individual pKa tables and whatnot, they do differ slightly based on the source. So just make sure you're taking a look at the source. There's no reason to memorize any of these values. Just know that you're doing this correctly. And of course, with something like, glutamic acid, we could continue going on, so on and so forth. We could deprotonate even further. So something around, 9.67. We could deprotonate even more. To deprotonate our amine, and then we're at a net charge of -2, but that doesn't really have anything to do with the Zwitter ion. So be able to calculate our PI and to be able to draw Zwitter ions.